Welcome everyone for this session classification of errors. I am P. Sendil Kumar, Assistant Professor, Department of Electronics and Instrumentation Engineering, Erode Sengundar Engineering College, Perundara. Measurement error. The measurement error is defined as the difference between the true value or the actual value and the measured value. So what is true value? The true value is the average of the infinite number of measurement and the measured value is the precise value. In general, the errors in measurement are classified into three types. They are gross error, systematic error, and random error. Types of error in measurement. So what are all the errors will occur? So errors classified into three, we already seen: gross error, systematic error, and random error. The systematic error is further classified into three types: instrumental error, environmental error, and observational error. The instrumental errors occur due to loading effect, misuse of instrument, and inherent shortcoming of instruments. Now we are going to see the errors. First one, gross error. It occurs due to human mistakes. For example, taking the wrong reading leads to incorrect data. It can only be avoided by taking the reading carefully. These errors are very common and the complete elimination is not possible. Some of the gross errors easily detected by the experimenter, but some of them are very difficult to find. So here gross error occurs due to human mistakes. So instrument shows the correct reading, but the observer taking the wrong reading. So the methods used to remove the gross error are: first one, the reading should be taken very carefully. Next, two or more readings should be taken of the measurement quantity. The readings are taken by the different experimenter and at the different point for removing the error. So these are all the ways to remove the gross error. Next one is systematic error. The systematic error are mainly classified into three categories. First one, instrumental error; second one, environmental errors; and third one, observational error. First is instrumental errors. These errors mainly arise due to the three main reasons: Instru- inherent shortcomings of instruments, misuse of instrument, and loading effect. The first is inherent shortcoming of instruments. Such type of errors are inbuilt in instrument because of their mechanical structure. They may, they may be due to manufacturing, calibration, or operation of the device. These error may cause the error to read too low or too high. If the instrument uses the weak spring, then it gives the high value of measuring quantity. The error occurs in the instrument because of the friction or hysteresis loss. This inherent shortcoming of instruments occurred because of the instrumental fault. Either it may show the reading very high or very low. Welcome everyone for this session Classification of errors. I am P. Sendil Kumar, Assistant Professor, Department of Electronics and Instrumentation Engineering, Erode Sengunthar Engineering College, Perundurai. Next one, loading effect. It is the most common type of error which is caused by the instrument in measurement work. So the name itself, loading. Loading is not proper. So for example, when the voltmeter is connected to the high resistance circuit, it gives the misleading readings. And when it is connected to the low resistance circuit, it gives the dependable reading. This means the voltmeter has a loading effect on the circuit. The error caused by loading effect can be overcome by using meters intelligently. So we have different ranges of meters. So why we are having a different ranges of meters? So based on the measuring range, we have to use a suitable meters for measurement. If it is not used, or if the instrument is not chosen properly, then it leads to error result, or we can't find the actual value of measurement. This is called loading effect. These errors are due to the external conditions of the measuring device. So it is environmental error due to the external condition of measuring device. Such types of errors mainly occur due to the effect of temperature, pressure, humidity, dust, vibration, or because of magnetic or electrostatic field. The following corrective measures shall be employed to eliminate this undesirable effect. First one, the arrangement should be made to keep the conditions as constant as possible. Next one, using the equipment which is free from these effects. Next one, by using these techniques which eliminate the effect of these disturbances. Next, by applying the computer corrections. So these are all the ways to eliminate the undesirable effects. So, in a jewelry shop, we can see the weighing system. It is a strain gauge based weighing system. It kept in a closed space or closed glass container. Okay, so in gold is the expensive one, and even a small amount will makes the huge difference in money. Even dust or any external influence, even wind can also influences the weighing. So it is kept in a closed container to make it a precise weighing. So this is an example. So at any condition, the weighing system is stable inside the container. So this is the one of the example for protecting the measurement system from external influences. Errors. Next one, random errors. The error which is caused by the sudden change in the atmospheric condition. Such type of error is called random error. These types of error remain even after removal of systematic error. Hence, such type of error is also called residual error. Random errors, we can't predict it. We can't predict, or we can't say this is the source for this error. That's why it is called as random error. So for finding the random error, we need a history of errors occurred during the measurement. So if we have the history, then we can say in this type of condition, this the random error may occur. Likewise, we can identify. There is no other way to predict the random errors. Only the history of errors is required to find out the random errors. Statistical evaluation of measurement data. Out of all the various possible errors, the random errors cannot be determined in the ordinary process of measurement. However, these errors can be treated mathematically. The mathematical analysis of the various measurement is called a statistical analysis of the data. For statistical analysis, the same reading is taken number of times, generally using different observers, different instruments, and by different way of measurement. The statistical analysis helps to determine analytically the uncertainty of the final test results. First one, arithmetic mean and median, then average deviation. When the n number of readings of the same measurements are taken, the most likely value from the set of measured value is arithmetic mean of the number of readings taken. The arithmetic mean value can be mathematically obtained as x bar is equal to x1 plus x2 up to xn divided by n. This mean is very close to true value if the number of readings is very large. So taking n number of or infinite number of reading is not possible. So at the most, how much it is possible, that much possible readings can be taken and take an average. That gives the true value, close to the true value. Finding the true value in a practical way, it is impossible because we need to take infinite number of readings, but we can make as many number of readings as possible and make an average. Then you can get the value that is close to the true value. For a set of measurements x1, x2, x3 up to xn is written down in the ascending order of magnitudes. The median value is given by x median is equal to x into n plus 1 divided by 2. The deviation tells us about the departure of a given reading from arithmetic mean of the data set. Ti is equal to xi minus x bar, where di deviation of ith reading, xi value of ith reading, x bar is arithmetic mean. In this session, we have seen different types of errors and statistical analysis of data. So errors are the ones these should be avoided during measurement. If you want to avoid something, then you have to know what it is or when it will be occur. That's why we are seeing different classifications of error and when this type of errors will occur. So once if you are identified the errors, then we can know how to eliminate those errors. That's why we have seen the different types of errors and statistical analysis. Thank you for listening this session.